All right, good morning everyone. Today I am making a video for 2A, which is on linear inequalities and interval notation. The main reason we're doing this is to pick up the interval notation. You should already know how to do the linear inequalities, but one of the best ways to do interval notations is to go over the the linear inequalities. So, linear inequalities are solved by methods similar to the ones we use to solve linear equations. The only real difference is in the multiplication property for inequalities and graphing the solution set, which we'll be going over here in a little bit. First thing we need to know about is the addition property for inequalities, which states if A is less than B, then A plus C is less than B plus C. So if you add something to one side of the inequality, you have to add it to the other. And this goes for subtraction as well. The goal is the same as solving linear equations. It's to get the variable on one side of the equal sign, or in this case, inequality with no coefficient, and it needs to be positive. So let's take a look at this right here. X plus 5 is less than 7. So we want this x all by itself. I need to move this, so I'm just going to subtract 5 from both sides. Okay, so I get x. Those are opposites, so they're gone. Less than, and this will give me 2 here. So x is less than 2. The solution set is too numerous to list. Any numbers less than 2 will cause the original inequality to be a true statement. So we can go one step further and graph the solution set to this. Okay, so if I were to graph this, let's say I got my line right here. I usually put on a 0 and whatever my number is right there. Okay, so because I am using this particular inequality, that goes with the parentheses or an open dot. Okay, so if you have a less than or a greater than, you want to use the open parentheses or an open dot. Okay, because I know what is coming, I am going to use the parentheses. Okay, and this means that it gets real close to 2, but 2 isn't included in the solution set. Okay, and again, you use that when you have a less than or greater than. Now, if you have x on this side of the inequality, this will point the way it's supposed to go. Okay, so at 2, I'm going to put a parenthesis, and it's going down this way, and it tells me any number less than 2 is a solution. Okay, so let's try another one here. I need to solve it for x. I need to get this to the other side, so I'm going to add 6 to both sides. All right, so I got x, those are opposites, they're gone, less than or equal to, and that's a positive 3. Okay, so this means that any number less than or equal to 3 is part of the solution set. Any of those numbers you put in there will make it a true statement, okay? And that's what we're looking for. Let's see what happens when we graph it. So I'm going to put a 0 here and a 3 here. Okay, now this particular problem I have a less than or equal to. And when you have a less than or equal to or a greater than or equal to, you use a bracket or a closed dot. And this time that number is actually included in the answer because it's less than or equal to. Okay, so it can be equal to it. Now again, because I have the x on this side of the inequality, This is going to point the way it's going to go. I'm going to use the bracket. It goes down this way. And there you go. Okay. Now let's do the multiplication property for inequalities. If A is less than B, then AC is less than BC if C is positive. So if whatever number you're multiplying both sides by is positive, that sign remains the same. And AC is greater than BC if C is negative. So if you're multiplying both sides by a negative number, the sign will flip, okay? And this is also true for division, because division is the inverse property there. Okay, so let's do this one here. 3x is less than 15. Again, our goal is to get x over here all by itself. So I'm going to divide both sides by 3. And I'll get x is less than 5. Okay, that was a positive number, so I did not change that there. Okay, let's graph this just for the fun of it. Here is 0, here's 5. All right, now remember, when you use this sign right here, that'll be a parenthesis happening at 5. This points the way it's going if you got x over there. So any number less than 5 will give me a true statement if I put it in here. All right, let's take a look at the next one here. Again, I want the x by itself. I need to move that -3. So move a -3 here. Those will cancel out, leaving me an x. But I'm dividing with a negative number. And when you divide with a negative number, you need to flip the sign here. So it's going to be greater than or equal to -6. Okay, so let's see what happens here. I have 0. Here's -6. Because I'm using this symbol, I need a bracket. Okay. So let's put, and it's pointing down towards positive infinity way down there. And it'll look like that. So let's just see if this works, okay? Pick any point over here and let's see if it becomes a true statement. I'm going to put 0 in there. So if I have -3 times 0 is less than 18. -3 times 0 is 0. Is 0 less than or equal to 18? Yes, it is. So that's a true statement. So this does work. Okay, this next one here, again, I want to solve for x. So I am going to multiply both sides by a -4. All right, that'll cancel that. Negative times a negative will cancel that out. I'm left with a positive x there. And because I multiplied through by a -4, I need to change my sign. That becomes -8 there. Let's graph this. Here is my 0, here's -8. Okay, so at -8, I'm using this right here, so it's a parenthesis, and it's going down this way, and there we go. Okay. All right, now on to interval notation. We need to be able to write our answers using interval notation, okay? And interval notation is a way to write solutions to inequalities using parentheses and brackets. So let's take a look at x is less than 2. Okay, so pretend that's your solution. I got this here, so I know I am using a parenthesis at 2. It's going to look like that, and anything down there. Okay, now what is way down there? Negative infinity. Now when we do an interval notation, we always put the smallest possible answer first, and then the largest possible answer after it, okay? And our smallest possible answer, this is pointing You know, it's got an arrow on it. It's going all the way down to negative infinity. Okay, so it'd be negative infinity. What's my largest possible answer? Oh, 2. Okay, now, infinities always go with parentheses. So if you have a negative infinity or a positive infinity, you're going to use parentheses like that, okay? Because I can always add one number to whatever you got there, okay? So I got an infinity, so I'll have a parentheses. Now it looks just like this. What do I got happening at 2? Another parentheses, so right there. All right, let's take a look at this next one. X is greater than 2. So at 2, I'm going to use a parenthesis. It goes pointing up in that direction, okay? What's way down here, over here? Oh, that's infinity. Okay, so let's write this in interval notation. What is my smallest possible answer? 2. And it has that parenthesis right there, okay? Then you have a comma. What's your largest possible answer? Infinity. Okay, so that, and because infinities always go with parentheses, there you are. See, it looks pretty much just like you have right above it on the graph. Okay, let's try this one out. X is less than or equal to 2. Okay, because I have this particular notation, I'm going to use the bracket. So at 2, I got a bracket. It's going down this direction. Negative infinity's way down there. What's my smallest possible answer? Negative infinity. What's my largest possible answer? 2. Okay, infinity always has the parentheses, and I have a bracket here. Okay, looks just like that up there. Let's do this one now. So now I have greater than or equal to 2. Okay, so at 2, I'm going to have a bracket, everything up here. So smallest possible answer, 2, and it has that bracket, comma. Largest possible answer goes infinity with a parenthesis, and there you go. Okay, so we're going to use this to write our answers in interval notation. Okay, let's go back to this first page we did right here. Okay, interval notation on this one. Smallest possible answer first, so negative infinity. It'll have a parenthesis, comma, largest possible answer, a 2, and that has a parenthesis. Let's take a look at this one. In interval notation, smallest possible answer, negative infinity. Largest possible answer, 3. This one has a parenthesis, this one has a bracket. Okay, if you use that, it's going to be a bracket. All right, let's take a look at another one now. We did this page here. Okay, interval notation on this. Smallest possible answer first, largest possible answer. This one always has a parenthesis, that one has a parenthesis. Okay, let's take a look at this one here. Smallest possible answer, negative 6. Largest possible answer, infinity. This one has a bracket, that one is a parenthesis. Okay, always take a good look to see what sign you got going on. All right, interval notation here, negative infinity to negative 8. Smallest possible answer, largest possible answer. That one always has a parenthesis. This one has a parenthesis there because you're using the greater than symbol over there. All right. Okay, so, let's do this now. So we got this problem right here. I want to solve it, I want to graph it, and I want to write my answer in interval notation. Okay, so the first thing I need to do is distribute here. I'll have 3x minus 12 is greater than or equal to negative 2. Okay, remember the goal is to get that by itself, so I'm going to need to move that over. So I'm going to add 12. I'll get a 3x, opposite, so they're gone. Greater than or equal to 10. Divide by 3, divide by 3. So x is greater than or equal to 10/3. All right, so I solved it. Now I'm going to graph it. Here we go. So here's 0, and here is 10/3. So I'm not even going to try to figure out the fraction part on that. I'm just putting it on 10/3. Okay, I got this symbol right here. That tells me that I am going to use a bracket. It's pointing down towards infinity, so this is going off in that direction. Okay, so we graphed it. Now let's write our answer in interval notation. Smallest possible answer, 10/3, and it's got a bracket that's going with it. Largest possible answer, infinity, and it always has a parentheses. So there you go. All right, next one here. So first thing I need to do is solve this. Let's see here. Okay, I am going to move this over here and this over here because I have y to the first power, and when that happens, I want all the y's on one side and all my constants on the other. So I'm going to add 8y. Add 8y. I'm going to subtract 7, subtract 7. Okay, opposites, so they're gone. That will give me a negative y less than or equal to. That'll give me a negative 3. Opposites, so they're gone. All right, now I need y to be positive, so I'm just going to divide both sides by a -1. That'll give me y. Now, because you divided by a negative, you need to flip the sign. It's greater than or equal to 3. Okay, so we solved it. Let's graph it now. So here's my 0, here's 3. Because I have this symbol, I know it's a bracket. It's pointing down towards infinity. So it's going like this, and I got infinity down there. Okay, smallest possible answer, 3. Largest possible answer, it's infinity. This one had a bracket. This one is always a parenthesis. Okay, so any number that you pick down here, any number, you could pick 10, you could pick -87, positive 87. Whatever number between 3 and infinity you put into this equation, it will make it a true statement. Okay. Let's see here. Let's try another one. So I got this one right here. I need to distribute. Oh, I'm still up here on this one. So I need to get all of my x's on this side, all my constants on this side. So subtract 5x from both sides, subtract 13 from both sides, and then I get opposites, they're gone, opposites are gone. That whole side zeroed out is less than or equal to. Okay, that will give me a 5. Opposites, they're gone. So is 0 less than or equal to 5? Well, that's a true statement, okay? But I also noticed in this problem that I lost all my variables, okay? So this one's a little bit different. It's a true statement, but all my variables are gone. So every number, every real number is a solution to this. Any number I put up in here will make it work. It could be -87, it could be 3,258. It doesn't matter. Whatever number I pick will make this a true statement. Okay, so if 0 is less than or equal to 5, which is true, that means there's going to be an infinite number of answers, and our answers will range from -infinity up to positive infinity. Okay, so when you lose your variables drop out. It's a true statement. You will have an infinite number of answers. So all real numbers will work, and this is called the identity inequality. I'm never going to ask you that, but just in case. Okay. Let's take a look at this next one. All right, that gives me a 10x minus 5 greater than 10x. Okay, let's move that 10x over because I like my variables over on this side. That drops out. I get -5 is greater than, and this whole side drops out. So is -5 greater than 0? Well, in this case, I have a false statement. All my variables are gone, and I'm left with a false statement, okay? That means no solution. There are no real numbers that will make this equation work, okay? And this is called the inconsistent inequality. All right, I'm going to add on a few more problems here and see you later.